Hello everyone, welcome back to the channel AI with Sumit. In the previous video, we have covered all the concepts related to the support vector machine, its uses, how the hyperplane is drawn for separating the two different classes in the data, okay, all the things, how the margin is, and what the main aim of the SVM, that is maximize the margin between two classes. Then model performs well for both seen and unseen data. Distance formula we have seen over here. So I encourage you to watch this video. And now today's lecture we are going to learn about K nearest neighbor. K nearest neighbor is also one of the supervised machine learning algorithm. Okay, and it's generally used for the classification, but also can be used for regressions also. If the problems are related to the regression task, then measure there is the averaging, okay, and if the problem is related to the classification, then there is a majority voting. Okay, it works by finding the k closest data points, that is the neighbors we can say, to the given input, mm, and make the prediction based on the majority classes for the classification and for average value for the regression. Okay, so what is actually the k and how the k is going to be decided? Okay, how the k is going to be decided. So k is decided by using the elbow method. We will see what is the elbow method in our upcoming videos in detail. So let's keep in mind, if our hand having the elbow over here, okay. um, Here's the elbow, okay. So where we occur the elbow like structure, then that point should be our kth value. In this graph there is not occurring elbow, there is not. Here we occurred elbow at the point 4. Then our k should be 4. Okay. So likewise, elbow method helps us to deciding the kth value. And just take an example. Without example, we cannot understand. So let's take a first picture. Okay. In the first picture, you can see that there are the two classes. This is the green one, that is class A, and this is the class B, and this yellow, suppose it is a C. Okay, suppose it is the C, and C is the new example to classify, and we have to decide that C is the member of, whether C is member of class A or class B. We have to decide that. Okay, so in the next picture we have to find that whether C is the member of class A or class B. Okay, for finding that we have to find the neighbors. Okay, if the k having here is k value is 3, and we have to find that the three neighbors of class A and three neighbors of class B from the data point C. Here this one is a data neighbor, this one is neighbor, and this is the third neighbor, and here also this is first neighbor, this is second neighbor, and this is third neighbor. Okay, and here you can clearly analyze that what in which class there is a maximum number of neighbors. By drawing this circle you can greatly analyze that there are the maximum neighbors of class B are there from the C data point. Okay, and there is only one data point is a neighbor of data point C. So the data point C should be the member of class B. Okay, I hope you got a better idea how the data point is going to be classified. Let's take over here a simple example. Suppose this one is the simplest example. Sorry. Okay, and there are two classes or three classes, suppose. Okay, this is the color green. Let's sorry, let's change the color of green. One, two, three, four. Okay, let's take the another class in the red format. Okay, and let's take another class in the blue format, dark blue. And if there is any new data point is coming over there, let's just, this is a class A, this one is a class B, and this one is a class C. Okay, A, B, and C. And if we are having we are having the new data point, that is yellow, which is come over here. Okay, then we have to decide that in which class data point D should be included, or in what which class the D is a member of, whether it will be the A class, whether it will be the B class or C class. So we have to decide that by finding the nearest neighbor. Then this is the yellow circle, okay, which is the new data point. Just finding if case value is 3. Okay, then just find the nearest neighbor of each class which are having limit of 3. Okay, this is the 1, this is 2, sorry, and this one is 3. Okay, in B class this one is A, 2 and 3, and in C 1, 2 and 3. Okay, just analyzing that by drawing a circle, you can clearly get an idea about in which class there are maximum nearest neighbor. So over here the yellow point is having maximum number who are the neighbors, that is class A. Then A will be the member of class A, which is green. So likewise, finding the nearest neighbors and classifying the data points is going to be done using the K nearest neighbor. I hope uh, you are having the clear idea right now. Okay, so we have taken the examples also. What is the actually K? How the K is going to be find by using the elbow method. Main concept where or for which problems we can use the nearest neighbor algorithm for classification also and regression also. If there is a classification problem, then just take the majority of the class, and if there is the regression, then just take the average value. So likewise, we can solve the problems and take the best decision for the classification. Okay, I hope I'm able to give the better idea in a simple words to you. Okay, if you having any problem regarding KNN algorithm, just drop your queries in the comment box. Okay, I'll approach all your queries, and if you like this video, then just subscribe to the channel, like or comments. Okay, just meet in the next video. Maybe the next video is the implementation part. We will see the how the supervised machine learning algorithms are going to be implemented. That is the coding part. Okay, and I encourage you to watch all these video which are related to the supervised machine learning algorithms, so you will be the best in every concept, and can implement coding part also in the well manner. Okay, so that's it for the today's video. Thank you so much, guys. We will meet in the next video. Bye bye.